Hello, this is the first lecture. In this material we'll talk a little bit about some of the good practices when programming in any kind of objective language. We already discussed a few of them. I'm sure that you know already some of them. But actually I would like to point out a few of the rules which are pretty important to know, both from the practical point of view and from the point of view of an interview or this kind of thing. So those are quite important things. We already know that whenever we are repeating ourselves, this is another way of kind of knowing that probably we should refactor our code. This is pretty simple. This is probably one of the first rules you learn about programming, is that whenever you are repeating yourself, you probably should create some kind of additional method or maybe class and split your code so that you don't have to repeat. And of course the problem are that if you're repeating your code and something will be changed in this code, you will have to find all those places and change the same part of code multiple places. We already talked a little bit about comments, and comments are something quite controversial, because if you feel that you really need to add a comment to a method or to your code, it may mean that your code is not clear enough. So it may mean that you should refactor something, change something so that the code is more clear. Maybe the names are not correct, maybe the method is too long. Of course, I'm not saying that you are completely shouldn't use comments, but if you are using them, make sure that you really need them. And a lot of times we say that code should basically comment itself by having good names, proper short methods, descriptive name of the variables, and so on and so on. Of course, unless or maybe you're just doing an open source library, then of course comments are pretty useful for all the other programmers. But if you are not, then remember, comments is something that may point you to the place which should be refactored. Program against abstraction. We already kind of discussed this, and to discuss it again, just to make sure you remember it, I will just create a small project on my desktop. Let's say that this is a console app, and I will just create a new class. Public class student. And just as before, student has a few properties. Int id student, string first name, string last name, and that's it. Now let's say that student also can attend multiple student groups. So I would like to create some kind of collection to hold those values. I will use list collection, which is pretty similar to array list in Java. And I will call it student groups. This class is completely okay. Let's say that I'm finished with it. Now I would like to use this class, and maybe let's assume that this class is used by multiple other programmers in different places in my code, and so on and so on. Now, student groups, and I will assign a new instance of the list, and of course now I can just add something. Now the code is completely okay. I can use this class. Let's say that this class, let's assume that this class is now used in multiple places, that I'm finished with it and all the other programmers started to use it. Now the problem with this class is that when it comes to this field, I'm kind of forcing other users to use this concrete class, this collection called list. And really there's no point in it, especially that I don't care what kind of collection someone is using. What is important for me is that I have a list of multiple students. I wouldn't really mind if someone would store it in a stack, queue, or anything else. So in this case, my two classes, student and list. Student is basically connected to a concrete class list, and I'm forcing other programmers to use this specific collection, which may not be the best choice for them. As you know, choosing the proper collections means choosing the proper algorithm, and sometimes different collection can solve specific problem much more easily. So what can I do to make this a little bit more convenient for the other programmers? As you remember, we already discussed that when it comes to other languages or C# or Java, one of the most important and useful thing to learn is our collections and also the hierarchy of those collections. When I will take a look again at the hierarchy of the collections in the C# language, I will see that, I will take a look, that all the collections are actually implementing iCollection interface and then implementing IEnumerable interface. And actually in C# all the collections are implementing this interface, which means that if I will just call it IEnumerable, now actually someone can use stack, can use hash set, can use any other collection they want. This is because I can use any subclass or class which implements an interface in the place where I assume or I will require this type, which seems pretty nice when it comes to writing code which is clean, which can be easily modified or changed. What else? Well, I have to remember that those hierarchy of classes is not random. So if I will just type SD student groups add, we see that I cannot add anything. This is because the interface IEnumerable specify only methods which allow me to use this collection student groups in the for each let's say loop. If I would like to add something, of course I could just force it and just kind of like this, just cast it to a collection, but of course this would beat the purpose of using interface. Yeah, casting to a specific type is not the nicest thing we can do in code. Now what is happening is that for a second I will just make small public my own collection and I will implement the IEnumerable interface. This is of course class. And as we see, the only thing that this interface specifies is IEnumerator method, which is used, the enumerator is used to use this class in a for each loop and so on. So what else I can use? If I would also implement the iCollection class, let's say with a string, we would see that this interface specifies all the other methods like clear, add, contains, and so on. So actually iCollection interface, I can enter it to take a look, specifies all those methods like add and remove, and IEnumerable specifies only the getEnumerator method. So is that so? If that's so, then I can just use iCollection, and now I'm still using the highest abstraction I can, which is this interface, and other programmers can actually still use other collections, and as we see, I can still add elements. So what is nice is that by using this highest abstraction I can, I make my code much more elastic when it comes to other programmers and how they use my class. So if you can program against highest abstraction, which a lot of times means program against interface. This is why interfaces are the backbone of objective programmers in Java, C#, in any kind of language. Much more than, for example, abstract classes, which you of course already know. However, you will see that abstract classes, you will find them not very frequently in code, but you will see a lot of time interfaces. Okay, I will get back to this. Now, the other rule which is pretty important and probably one of the most important rules of designing a class is the acronym called SOIT. This acronym describes how we should design a class in an objective manner. And this is one of the most basics, one of the most basic acronyms that you should know. Each of those letters represent one rule. Let's take a look at the first rule. First rule is single responsibility. Well, it simply means that each class we have in our code should have only, well, it is specified like it should have only one reason to change, but it simply means that each class should only deal with one thing, which means one thing usually from the business domain, but not only, yeah, depending on what layer of application we are talking about. So if this little single thing changes, then we have to change our code. So this may seem kind of vague. A lot of times we'll come back to this rule so that you will see how we are violating it in places and then how we are fixing it. But of course this is not math, so actually this rule is not easy. One of the there are really a lot of books written about how you should detect what is the single reason for a class to exist, how to find it in the business requirements, how to make sure that this class really deals with just a single thing and doesn't really do multiple things at the same time. So for example, if I have a class which reads the data from the file, then creates some students, then it displays an interface, and then maybe this class also does something different, then of course this class is violating this rule. We will talk about this rule today in a lot of times to just see that you are kind of, that this idea will kind of stick to you, and you will have more kind of intuition of when you are violating this and how to fix it. The open-close rule, the second rule, means that the class should be open for extension but closed for changing the implementation, which may seem like this. We already did this kind of example. I will create an enum. Let's call it diet. Let's call it diet for fat, for slim. Well, maybe not for fat. Let's call it for slim diet, no gluten diet, vegan diet, and let's call it vegetarian diet. Okay, now each student has a single diet. Current diet. Now, let's say that I would like to create a method which will calculate calories depending on the current diet. So in calories we will have some kind of algorithm in this method. Let's say we switch on the current diet, in case we have a slim diet, the calories will be, I don't know, like 1000 or something. And of course here we would have some more complex algorithm to calculate this, maybe depending on the weight of the student or some other things. We don't really care. Let's just implement all the other types of diet. Okay, so this is my algorithm, and at the very end I'll just return this integer with the number of calories. Now this may seem okay. Let's say that of course here we have some more complex way in which we are calculating this. However, we should remember that whenever we have some kind of long switches or long else-if statement, it usually is an information for us that we probably could refactor this. Second thing, using switch is kind of controversial. In a lot of the companies, using switch is basically forbidden for one of the simple reason. If we would forget the break, we know that the code will follow through to the next case statement. And when we see something like this in code, we are never sure if the other programmer just made a mistake or maybe he did this on purpose. So those kind of mistakes are pretty hard to debug later on and kind of force me to read through the whole code and just see is this really makes sense or not, or just ask the other programmer. Yeah. Okay, but that's not the point. Let's just say that our method is finished. Unfortunately, we need, let's say that this class is used in multiple places. Our program is just in development, on the production, and so on. And after some time, we decided to add new diet. Let's say that we call this diet let's say this is the meat-only diet for some reason. And of course, I would like to add a new algorithm in here. Well, of course, I could just add new case statement, but that is pretty problematic. First, I'm doing now exactly what I shouldn't. Whenever some of the requirement changes, now I had to change the implementation of the student method. In this case, it was pretty simple, but in real time, in a real-world application, maybe I don't even have access to the student class, and I cannot change the implementation. Secondly, whenever we are changing the code which is already used, we are changing the implementation of it, we are creating a risk of introducing more bugs into the code which already works. Not the best thing. I would like to be able to change this algorithm, this diet, by just creating some classes, or by doing something different than just changing the implementation. How we could do it? Well, we could do it in two ways. For example, of course, there are multiple ways to do it. First, someone could say that we could create a new student, and I could do something like this. I will create a single student, let's say public class, let's say vegan student, which will implement our student class, or sorry, inherit from our student class. And let's say that in my student class, I could create, I will just, for a second, I will just comment out this calculate calories method. I'll just leave it. And now what I will do is I will create a method, and well, we can do it in multiple ways. I could just create a method, again, get calories, and well, I don't have any base implementation of this method, so I could even maybe, well, if there were to be a change, I could do something like, I don't know, create an abstract class, then create an abstract method, public abstract int calculate calories, and then, well, actually, and then nothing, because this is just a signature which has to be implemented. Now in this class, of course, I have to implement this method, and if this is a vegan student, I can implement the algorithm and just return whatever was the number of calories for the student. And of course, I could create the same thing for the other student. And now it would be pretty nice because I could just loop through all of the students, just run the method calculate calories, and thanks to the polymorphism, I would always run the algorithm specific for a specific type of student. And if I would like to add a new algorithm, I wouldn't change anything in our existing code. I would have to add just new class, extending from student, and creating a new algorithm. So this is one way. Well, second way, which is pretty often also visible, a little bit maybe similar to strategy, the design pattern called strategy, is that I could promote the diet to a separate class. So I could create a class diet, and inside this class I would have probably some fields, maybe string the name of the diet, and of course some other things. And in here I would have my calculate method, like this. And of course, I would just create a new instance of this diet object. And I would create a new instance of the diet object for each specific diet. and I would basically change the move the algorithm to a separate class, which is something that you will often do. So often, a lot of times when you first create your structure of code, you will see that some of the things from the business domain are later promoted to a separate class, and this is something that happens quite often. Okay, so I hope that this kind of shows what we mean by this open-close rule. Now, the list of substitute principle, the third rule. Well, we kind of already discussed this. This was this example when we're using the collection, but we decided to use more abstract type. List of substitute principle tells us that whenever we're using the abstract type, like abstract class or maybe an interface, we can substitute the subclass or the class lower in the hierarchy for this specific type. And this is how C# language and Java languages are work. Thanks to this list of substitute principle, we can exactly do what we did in here when we were discussing this highest abstraction, programming against highest abstraction. Now, interface segregation. Well, this is a little bit harder to describe, so I will just close those elements for now. And what I will do, I will create an interface. And let's say I will call the interface I, because this is the syntax. I always type with the I, and the convention, I person. And I will create some methods. First, some attributes, let's say properties first name. I don't need this public keyword because this is an interface, so by default all of the things are public. Last name, I will create some method called int, or maybe double, calculate average grade from current semester, and maybe some other method like int calculate salary for the teacher. Of course, I don't need those publics in here. Okay, let's say that that's it. So this is a small, and then may I have some multiple other methods or properties in this interface. Now, I'll just create a public class student, or maybe I'll just use the student class from the previous example. Maybe the new one. Public class student. Of course, the code doesn't compile. I'm just kind of writing pseudocode, which implement this interface. And of course, I have to now have and implement all those things in my class. So first and last name, calculate average grades, calculate salary. Of course, this throw not implement exception is added just for us to remind us that we should provide the implementation for it. Now another class is called this, and this is a teacher. And the problem is that our interface is not granular enough. For example, for the PIATK student, I have to implement the calculate salaries method, which probably a lot of time will be simply just an empty method returning maybe something. And let's say that I implementing this method only because I have to, because I kind of forced to. This was of course a method, and this should also be a method, of course. Okay, and I will just fix it. This was supposed to be a method, and I made a small mistake in the interface, which I have to fix now. Okay. This is just some average grade. Okay, so now I implemented both of those methods, but actually I need only this one, because let's say that the student doesn't have the method calculate salary. But still, because this interface specifies it, I have to implement it. In a lot of times, in this case, I will just leave an empty method like this, just to have something, because just to have this method implemented. And in the teacher class, I would do the same, but I would leave the calculate average grade method empty, and I would just leave, and I would just implement the calculate salary. So it means that the interface is not granular enough. Probably, it would point us to the conclusion that this interface deals with with multiple things. So it doesn't have the single responsibility. This interface deals with a lot of things at the same time. So it kind of forces other programmers to implement methods that they don't really need. So it looks like they need only a subset of method in their from this class, which probably should point us to refactoring this interface and splitting it to more than one interface, maybe two, maybe three. Even in Microsoft, even in some built-in classes, you will see, let's say in C#, some of the older interface sometimes are implementing a lot of methods, and when we want to use them, we have to implement a bunch of methods which are not really needed by us and are not kind of used by us. So this is how it is. We should make sure that the interface, just like a class, deals with a single thing, and that if someone will use this interface, we want to make sure that he will need all of those classes. Now the last rule, dependency injection, which is pretty important and very often used, and you probably maybe even saw this term already. Dependency injection allow me to write code in more modular way. There are even frameworks to solve this issue, and we will use those kind of libraries to do it, but for now, let's say that I will do just a small example. And those small examples are pretty useful to remember because, well, you may be asked quite often to explain the SOLID acronym, and in this case you have to kind of explain why you did something in a certain way, or how you can implement the single responsibility rule, and so on and so on. So in this case, I will just create a class, and I will call this class a car. And car can have, let's say, a model, a number or something, and let's say that car can have an engine, and let's say that engine is a separate class. Engine has also its model, and of course can have multiple other things. Amongst other, I will have public void start method, I will have public void stop, and of course multiple other methods. Let's say that I'm using this class in here, so I'm using the diesel, or sorry, let's call it maybe, let's say that this is a diesel, and I will call it engine. And even in the constructor, I will create and assign a new class. Now, our classes are okay, they work. However, this is not the best way to write it probably, or of course depending on the requirements. But in this case, both of my classes, diesel and car, are very tightly coupled together. What we are usually trying to do is that within a single class, all of the methods and properties should be tightly coupled. That's okay, because this means that they describe the same thing. But classes, concrete classes, shouldn't be really tightly coupled, as we should create as little connection between classes as we can. Of course, we cannot remove those connections, those association, because classes or objects have to communicate with each other. But we should try to make those association as little as we can. We shouldn't create too many of them. In this case, the car class is tightly coupled with a diesel class, which means that basically car class cannot exist without the diesel class. Secondly, my car has a public constructor which doesn't require anything, and then somewhere under the hood, I'm just creating a new concrete class diesel. So this tightly coupling is even hidden from the other programmers. When they will be using my class, they don't even see that under the hood they're also creating the diesel instance, and that this class is used with the car, and so on and so on. So this is probably not the best thing to do it. The nicest thing to have is that I would like this class to, by using the constructor, to tell the other programmers that I want diesel engine, and so that other programmers can submit a class. And now it is a little bit clearer that a car class cannot exist without an engine, without the diesel class. Now it's a little bit clearer. In the most elegant way, we would like to have our classes declare all the required dependencies in the constructor, and if I will submit or fulfill those dependencies, I would make sure that this class will work correctly. Okay, so of course now I can go to the program class, program, and in the main method probably I have to, if I would like to use this class car, new car, and I would have to specify new diesel. Well, it is a little bit clearer now for the other programmers, so this class is a little bit nicer, but still I'm forcing the user to always use the diesel class. Those two classes are still tightly coupled, however this is a little bit more obvious now. Now, what would be probably better is to give the client, so to the person who is using my car class, the power to change and to inject the dependency to another class for the constructor. But this dependency, which is now injected really by this, can be any other class. We don't want this to be tightly coupled to the diesel class. So to do it, I will just create an interface. I will call it iEngine, and I will specify that each engine has to have a model, has to have void start method, and has to have void stop method. And of course, I don't need those elements. Of course, the diesel class will implement the iEngine. However, I can create another class, let's call it public class electric, which also will implement iEngine, and I can make this also implement this. So now I have two engines. I will just leave this implementation like this: electric engine and diesel engine. And now I can cut the connection to a concrete class, to a diesel class, by using the interface. And now what happened? I basically reversed the injection, the dependency to the engine, to the diesel class, from this class, from the constructor, to a client class, which now in here can submit diesel, can submit electric, can submit anything they want, and car class is not tightly coupled to a diesel class. Moreover, if the need arises and I will have to create a new engine, I won't even have to touch this class, which kind of is similar to this rule open close. I can just create a new subclass of the engine, iEngine, class which implements iEngine, and I can just use this class in this class, because here I'm using an interface. I don't have to change this class. So still my car class is close for changes in the implementation, but it's open to anything else, to communicating with new classes of the iEngine, even those that haven't really existed yet. So this is how it works. This is how we can write modular code, and how we are basically reversing the dependency to the iEngine to the client code. So this is pretty similar. Of course, if you will take a look at this, you may seem that okay, but probably if I will write code in this way, I will have hundreds of classes which require some kind of setup, require some kind of instance of the class. This is true, and this is why later on we will use framework called dependency injection frameworks, which are using something which is usually called dependency injection container. And now this is pretty kind of pretty typical thing to use those frameworks. We'll see how it works, but if I will just show you kind of pseudocode of how it works, I would say something like this. Let's say we have a class DI-config. Usually I have some single method, let's say called config. And by using this dependency injection framework, I can tell something more or less like, let's say, setup, provide, let's say, diesel. So I can say, by using a single line of code, that all of the places in my code which are requiring the iEngine provide the new instance of the diesel class. So those dependency injection framework allow us to create those kind of configurators under which I can configure my whole application and say that if this interface is required to use this class, I can just kind of think about my application like a bunch of blocks which I can move around and connect in a way I want. So this is really pretty much this is the kind of objective way of doing this. Yeah, we see this really kind of allow us to think about our application like a bunch of loosely coupled objects which we can connect any way we want. Of course, don't worry about this. We will use those frameworks later on, so we will see how they works. And those are all the rules that I would like you to remember, and those are the things that you should remember because this is really practical. You will be asked those questions a lot of times, and it's pretty useful to be able to just make those small examples and make sure that you understand each of those rules correctly. And we will a lot of times get back to those rules and see why we have used them and so on and so on. Okay, now I will just close it and I will open the project that you did during your classes. So Piat Academy, I have it somewhere in here. Let's say desktop, Piat Academy. I will just open it, and we just have an interface which we have to in which we have to implement a few things. I'll just close this for a second. Okay, so I'll run this code just to see how it looks. We have some data, we have some grid view, we have also a separate form as a dialog box to adding students. Okay, we have to implement some things in it. Implement the data access layer. Okay, so what we would like to do. First, I will start with my database. I will connect to my local database. You can connect to DB, MS SQL, and in here I will just create a database. I'll just call Dean's Office. Well, I think it will be like Dean's Office 3 or something. Okay, I will just create a new query. And I will create a table. I will call it students. For now, I will make it much more simpler than the application requires from me, just to see you through all of those steps that you require to implement data access. Well, let's say that I will make this class for now pretty simple. Primary key, int identity. So this field will be auto-generated by a database. And I will use also first name, varchar 50 not null, and last name varchar 50 not null. I will just run this code just to generate my table. Of course, I should specify the data type first. Okay. Now I will add some data. I will go to my Management Studio table, select my students table, and right-click, edit. I will add around 3 records just to have some data in it. So Jan Kowalski, okay. So that's it. I can close it. I have my database ready. Of course, there's much more columns in there required. I don't worry about this for now. Next thing, I will create the folder called models, which is usually used to store our business related objects, which will model our business domain, which in our case means data from a database. Right click, add class. I will add new class and I will call it student. As we see, the namespace fits the physical location on the drive, and this is of course okay. ID student, first name, last name. Okay, so my student class is finished. I have just 3 properties, just like the table in the database. Now I will get back to my code behind, and let's see that in here I will create a private method void load data, and now I would like to use the classes that we already know, SqlConnection, SqlCommand, to fetch the data from the database. Also, I will make sure that this method is executed from the constructor. So I will create the connection class, which is an instance of SqlConnection. Now I will create a command class, which is instance of SqlCommand. We already know this class. SqlConnection represents a connection, SqlCommand a comment to database. So, okay, before I can start, I have to set up my SqlCommand, so I have to at least set up 2 things, connection and comment text, to, for example, select star from students. Now, the next thing is to open the connection before I use it. So I will just open it. Now I can use the command.execute reader to execute the command and get the data reader, which is a forward only object which allows me to read records step by step. And then I have to use, let's say, a while loop to read the elements step by step from this Of course, each time I'm using the student, I also have to add the proper using statement in here. I'm just adding it automatically because that's what Visual Studio does for me. Each time I will loop through new record, I will create a new student. I will set up the fields of this student, like so. And so, and then last thing is I will add this new student to my collection. And then I will just return, or maybe not a return, but actually use my students data grid view data source property to assign the list of students as the data source. Of course, I should close the connection, but still, well, instead of this, I can use the using block that we discussed during the second lecture to just close automatically the connection whenever the code reaches this line. Now, what else I could do? Well, actually the data reader class, which I'm using here, is also a class which I can dispose of as soon as I finish with it, so I could do it like this and just add another using statement. Now I have to move this class, of course, a little bit higher. Okay, what else? Well, my SqlConnection requires one thing, which is connection or connection string to a specific database. Now to do it, I will go to the Server Explorer. I will add a new connection. Of course, I will add connection to my local database. You would add connection to your own local database or maybe the MS SQL. And I will choose Business Office 3. Click OK. And now I'm connecting to my database. Now, when I will look in the properties, when I will select my database, in here I have my connection string. I can just copy this from the properties window, get back in here, and just paste it. As we see, we have data source specific to my computer, initial catalog specific to a database. Integrated security means we are logging using the Active Directory, our credentials from Active Directory. Now I can just run it, and we see that it worked. I have my 3 records from database displayed in my data grid view. Now it works, okay, but we have a kind of problem with it, and we will deal with this problem during our next week classes. So you don't have to worry about this now. Well, the problem is that my code or my main form class doesn't really conform to a single responsibility. The responsibility of this main form class should be just displaying visual interface, yeah, GUI. But I'm actually also getting the data from the server. I probably will implement some business logic in here. So my main form class will kind of mix together presentation layer, data access layer, and also probably business domain. So not very good. We could kind of refactor it a little bit. To do it, to try to do it and see what are the benefits of it, I will create a new class, a new folder, call it DAL, which stands for Data Access Layer. Inside of this folder, I will create a new interface, and I will call it iDINS Office DB. Inside of this interface, I will specify for now a one method, which will be IEnumerable student get students. You see that I'm using this list of substitute principle that we used before. Instead of just specifying that this method will return students, list of students, I'm specifying this general type so that we know that it can be anything. It makes our code more elastic because later on, if I will have a need to change the collection used by getStudent, no problem. I don't have to change the signature of it. So I will just leave it as IEnumerable. I will create a new class. Or before I do it, one more thing. Even the load data method doesn't have a single responsibility principle kind of implemented, because we're doing two things at least, or even more. I'm connecting with database, I'm parsing the result back, and I'm displaying this directly in the grid view. So this method is doing multiple things at the same time, which means that I cannot really write a unit test for it. We will later see that writing unit test is pretty useful, not because we are testing something, this is of course one thing, but because we will be thinking about our code in a more objective manner. And this means that this method cannot be really tested by unit test because it's not written in a correct way. I will create a new class and I will just call it mock DINS Office DB, and this class will also implement the iDINS Office DB. And in here, I will just, let's say that this is mock implementation. So let's say that maybe programmers haven't really finished the database, but I don't want to be held back. I want to work on my application, so I just created this mock class, which will just, as we see, return some, build some kind of fake students, which will be just kind of, which will come from this static method, not static method, but this will be just some static data, not read it from a database. Now I will just leave it like this, and I will create a new instance, which I will call SQL Server DINS Office DB, let's say, and this class will actually use a real database. I call it SQL Server because this class will be using our SqlConnection, SqlCommands, and we need that those two classes, SqlConnection and SqlCommand, can only work with SQL Server. So I will just copy this whole thing. I will just move it to here. Of course, I cannot assign anything to data grid view now. What I want to do is I will move this list to this place, and then at the very last step in this method, I will just return a list of students. So now we removed from this method one dependency to the responsibility of assigning this list of students to already the interface, the data grid view. So now this method is a little bit more clear in terms of what this method is doing, and now I could probably write maybe some kind of unit test for it, but still not really, because this class has some tight dependency to those classes. So what else I should do? Well, to make this code a little bit, to refactor it a little bit more, I should probably move this connection string to a separate variable. We talked about things like magic numbers or magic strings. Whenever you have some kind of string value or some kind of weird numbers directly written in your code, maybe except 0 and 1s, they are usually called magic numbers, which means we don't really know, or other programmers won't really know why they are used there. So it is much more kind of nicer way to just split this code to a separate variable. In Java you would use public static final. In here I will use public const string, which means that now whenever I will want to use this connection string, I will have this one static field, this const field, which I can use. So now code is getting much clearer. SqlConnection, and this is database connection. So now it is getting more and more clear. Well, it still isn't too good for many reasons, but now this code is a little bit better. We can say that we splitted our data access layer from here to separate class. So now I can just remove this load data method, and I can make this much clearer that main form requires data access layer. So I just require an interface called db, and in here I can just type, I can make this setup again, data source is equal db get students, and that's it. And let's say, let's go to my program. Now we see I can provide it, let's say that my database is not ready, but no problem, I can just set this to an interface of mockdb. I will just execute this, and it works, no problem. Now my database is ready, no problem. My code is like a bunch of blocks which I can connect any way I want. I can just create a new instance of SQL Server, this OfficeDB, run it, and the code works. So what is nice is that I can very easily switch those elements because I kind of cut out one of the responsibility of the main for class, which was data access, to a separate layer called the separate class data access layer. And this is a way, I hope so, how we can make our code more modular a little bit. And of course, we will dive into it more during our next class. So I hope that now you can try to implement the rest of the logic. And probably today I'll also upload another material which shows you step by step how to do this, the rest of it, the rest of the implementation step by step, and how you can make it better. So I hope this was clear, and that's all for now.